we run prediction logging tool or prediction logs in cased hole. The first the first objective for this PLT, it is to monitor reservoir performance and variations like flow profile and what is in the flow profile, perforation and so on. The saturation profile. The second one of why we run a prediction logging tool to diagnose well problems. So maybe someone ask what are well problems? Well problems like water entry. What is water entry? Water entry it is the point in the well bore that the water it is producing from it, and you know, in the production of oil at all oil fields, we don't need any water cut. So PLT diagnose where is the water entry and what is the amount of water. Okay, that is named as water cut. Okay, the other problem, gas entry and leaks and mechanical problems. Okay, leaks in the well bore and other mechanical problems like integrity issue in the casing and the other problems like flow behind casing. And we will discuss and explain the corrosive flow and what's the relation between the PLT and the corrosive flow. The other causes for why we run PLT for guidance workover and enhanced oil recovery. Okay, we can see here the PLT toolset ring and the parts sensors of this tool. In the bottom of tool you can see here this shape. It is named as spinner, and we can see this gauge for the centralizer, and the other sensor we will explain the sensors. So what are the application of PLT? You can see here the image this slide. Okay, you can see the track of temperature, track of the apparent water holdup, density, pressure, and the track of the amount. Okay, all these properties it is got from the PLT, and it is the main the main properties we can get them from this tool. Okay, this is the sensor here, and here the spinner. Actually we have two spinner, inline spinner and a gauge full bore spinner, but the important one, it is the gauge full spinner. Okay, because the whole of flowing of for the fluid will be begun and face this spinner. The other sensor, it is capacitance, and sometimes we read dielectric. Okay, and this capacitance or named as dielectric, it is the opposite readings for the density. We will explain that in the PLT curves, inshallah. Okay, so there are two important points for the sensor of density. Okay, someone can say this is a question. What is the usefulness of density measurement, density sensor? The first one for determine volumetric flow, okay, and the other one show entry points. And what we say in the first slide or two slide, the second slide, yes, we say the PLT diagnose some problems like gas entry and water entry. This is show by density. Okay, so actually, I want to explain the basics of this PLT. So there are a lot of informations of this tool. I will not talk about it, just the general view. PLT conditions. There are two types of conditions for the PLT, flowing and shut-in. Okay, these images that is captured from the software that is used in for this tool. It's named as Plateau. Okay, this Plateau can show me the readings of the spinner and the readings of the apparent, and after processing these readings, we can see the amount of oil, the amount of water, and you can see here the partial amount for the oil and water. This CPI of tracks that show the amount of oil and amount of water, the partial amount, and the other tracks for open hole like permeability, resistivity, and the gamma ray. All these tracks, it is very useful to make interpretation for my well, for my job, and any case we want to know what we should handle with it. Okay. So in this slide, we can show the problem. We diagnose it by PLT. So what is this problem? This problem it's named as crossflow. So what is a crossflow? Crossflow can be can be happened in the bottom of the well or in the middle of the well. Anyway, but I want to say the crossflow can be done from the zone has high pressure to the zone has low pressure. Okay, so the fluid will flow from the bottom zone to the top zone, or maybe otherwise in the opposite meaning, from the top zone to the bottom zone. It is depend on the value of a pressure. Okay, so this case can be diagnosed by PLT. Okay, so when you run the PLT to face the flow of fluid, okay, a spinner, by movement of a spinner, can know there are some fluids in the whirlpool. But in the PLT you have a lot of sensors, okay, like pressure. So when you take the curve of pressure and take a look for this track, and you can see the point, point of pressure, where is the decreasing, where's the increasing. Okay, so you can diagnose by PLT the cross flow. This slide shows us some variables, some properties, or we can say any term for that, but these curves, it is the PLT sensors. Okay, you can see here temperature, pressure, density, dielectric, line speed, spinor, gamma ray, CCL. So someone can ask, how can you read this curve and tell me the useful of these curves? My brother, I want to say these curves, it is the PLT. Okay, so when we start to read the temperature, we'll start from the bottom. You can see here PLT, the value will be changed. Okay, you can see the change here, yeah, and the change here. So these points of changing temperature, what can give you, okay, what the imagination that can give you this changing of points? Tell me. We can say there are some fluids movements in the whirlpool, but what the types of these fluids we can't recognize, right? But there are some variables can't tell us the types of fluids. Follow me. Pressure here is stable, so the well is stable. But the density here, when we follow it from the bottom, the values of the density will be changed, right? So change from value like 1.1, then will be go to 0.9, 0.8 until to 0.7. But when you compare these points of changing density with the point changing of temperature, you can know there are different fluids. And I think all petroleum engineer, all geologists, or another one know the density of oil and density of water, can recognize here was water in the bottom of the well, but in this area, yeah, there are some movements. There is a fluid flow from here, and these fluids different, okay, and dielectric make the same evidence for that. Okay, when we go to another tracks like spinor readings in the same points of different temperature and density, you can see here the movement of a spinor will change also. Okay, my friends and brothers, I want to thank any one of you. This example will be to you. Okay, so you should read gamma ray, temperature, pressure, density, spinor, and make comparing between other. This example from Romela oil field, and you can see here a lot of tracks. We said in the beginning, this the open hole tracks, and these tracks for cased hole, like this for the sigma and CO, or for the saturation logs. But here, the tracks that is got from the PLT. the amount of oil, amount of water, this perf, yeah, this perf of oil, and these the partial amount of oil and water. Well, and you can see the changing of temperature here. Thank you very much for watching, and to follow this presenting.